Well, next time we do something exciting, maybe I'll. Okay, we'll do that tomorrow.
Grab some pictures of our class.
You remind me. Yeah, Riley. Okay. Okay, so today we're going to continue talking about oblique triangles, but now we're going to solve them with the law of cosines. On the next slide, I'm going to show you three formulas. You really only need to write one of them down. The law of cosines formula involves three sides and an angle. Okay, if you write one of the formulas down, you can rearrange it based on whichever angle you're using. Okay, now let's just recap really quick. The law of sines we used when we had angle, angle, side, angle, or side, angle. Okay, now that we're in the law of cosines, what's one that's missing? Side.
Side angle.
And side, angle, side.
Sass.
Yes. There's some sass. Okay? These are the ones you need to use, or these are the scenarios that would require you to begin with the law of cosines. Okay? Here is the law of cosines formula. Like I said, it would only be, you would only need to really copy one of them down. And I'll show you how the other two can just be rearranged. Okay? Okay. Okay, so do you see how this is involving three sides? A, B, and C. Now, which angle do we have? Whichever side is the loner over here on the other side of the equal sign, then that is the angle over here inside of cosine. Okay, look at the other two. We have all three sides present. Whichever one's the loner, that's what matches the angle on the cosine. So we have side squared equals side squared plus side squared minus 2 times these same two sides times the cosine of the angle that matches the other side. Okay, so we are going to do 2 examples. Okay, here's our first one. Did I spell it wrong?
No.
No.
Yeah.
Sorry. Okay, so if we draw this out here, A is 55 degrees, B is 3, C is 10. What given information do we have? Side, angle, side. Okay? That's some sass. All right. This means we need to use law of cosines. And since law of cosines involves all three sides of our triangle, the only thing that we are able to find would be side A. Okay? So what we're going to do to set up our law of cosines formula, we're going to write A squared, that's the side we're solving for, equals side squared plus side squared minus 2 times those two sides times the cosine of the angle across from our loner side, which is A. Okay? Please do not work ahead of me. Okay? I want you to be efficient with your calculator. I don't want you to have to hit equal sign 3 or 4 times for this one side. Okay? Let's think about this. Can we punch all of this into our calculator? We can, and we would get some number, and that number would equal a squared. And what would we have to do? Square root it. So do you agree that we're going to have to take the square root of both sides, which means we have to take the square root of that big mess, right? Mm-hmm. So in your calculator, let's do that. Let's take the square root of, type it in exactly how you have it written down, 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of, was it 55?
Yeah. You times 2 times 2.
And it should be 3, shouldn't it? Thank you, Monique. Okay, like that. And you only have to enter something in your calculator. Okay, I want you to be efficient with your calculator. So our side is 8.64. Is that what you're getting?
No.
Hold on, Monique. You're reading.
That'll do it. That'll do it.
Okay. So now what? Now I need to find an angle. How should we do that? Can we do that?
Heck yeah.
Heck yeah.
So now that we know side A, technically we have 2 sides and an angle excluded. Okay? Please listen very carefully. I know that you're going to be able to do what our next step is, but look, pencils down and look at me. The only time you will ever have 2 triangles is a given side-side angle case. What were we given here? We were giving side, angle, side. We will not have 2 triangles, even though we're going to switch to the law of sines. Now, we have the ambiguous case for side-side angle because our calculator only spits out an acute angle for inverse sine, and we have to think about its supplement. Do not switch to law of sines and find a potential obtuse angle. Law of sines is not going to get you that obtuse angle because inverse sine will only spit out an acute angle. So never, ever, ever will you find the biggest angle of your triangle if you are going to switch to the law of sines. Save that for last. Okay? So our biggest side is side C. I am not going to use the law of sines to find angle C because it could be obtuse, but the law of sines is not going to give me an obtuse angle. Okay? So which angle should we find? I have no problem with you using the law of sines after we find the law of cosines once. No problem. But be smart about it. So we can do the sine of B over 3 equals the sine of 55 over 8.64. What do you get down? Did you do the inverse sine of that? Okay. 16.53. question about their calculator and getting to the 16.53. Really?
Well, I got 16.32.
Oh, you need to do the times 3. All right, so what's angle C if we use the 180 rule? Hmm. 108.47. Okay. Now, I'm going to take a little side note here. If we would have set up the law of sines with angle C first, okay, we would have gotten that angle. That's not what we got, is it? Okay. If you try to find the biggest angle with the law of sines, you don't know if it should be the acute or the obtuse angle. Okay? Which is why you need to avoid finding the biggest angle with the law of sines because of the ambiguous case. If you want to be safe, you can just use the law of cosines the whole way through. Okay? Or you can use thinker. Don't find the biggest angle with the law of sines. Okay? Can you remember that? Okay. Let's try side, side, side. Please don't do that. That would be silly. Side, side, side. Okay. When we have all three sides, that means we need to find an angle using the law of cosines. Okay? And this is probably where the law of cosines is the most annoying because of the way we have to solve it. When we had side angle side, solving for that third side, we just like plug and chug. Okay? Here we have to be a little bit more careful. Okay? So, knowing that we like the law of sines, and we're going to want to switch to the law of sines after we find this angle, which angle do you think would be a good one to find with the law of cosines? I would say A, because we're using the law of cosines, it would be a safe one. And then we don't have to worry about which one we find with the law of sines. So let's find angle A, since it is the biggest. So that means we would have side A squared equal to side B squared plus side C squared minus 2 times side B times side C times the cosine of angle A. No. Okay, so let's think about how we do math. We need to solve for the cosine of A. Can I just throw everything on the other side right now? What can we move over? We can take these two and we can subtract it over, right? We can take 34 squared and we can subtract over 20 squared and 18 squared. Okay, but negative 2 times 20 times 18 is tied to the cosine of A by multiplication. Okay, so in your calculator, we can take that 34 squared and we can subtract over, was it 20 squared and 18 squared? Okay. Okay. So we have 432. Can somebody tell me what negative 2 times 20 times 18 is? Negative 720. Okay. Now, you don't have to put all of these steps on your paper, but what's happening is we have that 432 and we're dividing by negative 720, and that's what the cosine of A equals. So if we take 432 and we divide by negative 720, we have negative 0.6. We need to do the inverse cosine of that angle to get the A out of the cosine to solve for it. So our angle is 126.87. Was that what it was? Okay. That takes a little bit of work, doesn't it? Okay, but I need to stress that you subtract over these two squared sides, but then after that, you would divide this product over, okay? Please make sure you do your order of operations correctly, otherwise you're going to get screwy-looey. You will never get a no solution for a triangle with side, side, side. So if you get an error when you do inverse cosine, something is wrong with your algebra. Okay? All right, so let's continue. How many of you like setting up the law of sines better than the law of cosines? Okay, to find an angle especially, that was, like I said, kind of obnoxious. Okay, it takes less effort, that is for sure. Since we have found the obtuse angle, and not every triangle will have an obtuse angle, but there's always that potential. But since we found the biggest angle, we don't need to worry about which angle that we pick, but let's just go in alphabetical order. The sine of B over side B would equal the sine of our new angle A, or our found angle A, over side A of 34. Okay. So multiply this 20 over, and since the sine of B equals that in your calculator, please take the inverse sine of that quantity. What do we get? 28.07. Can we confirm? Yeah? Which means if we add up to 180.16, no, 0.6. What? There are three angles. If you want to stick with the law of cosines the entire time, I have no problem with that. But if you're going to switch to the law of sines, make sure you be smart about it, and you're never going to find a potential obtuse angle with the law of sines. Never find the biggest angle if you are going to switch to the law of sines. Okay, there is one more area formula that I want to teach you about. It's called Heron's formula, and you learned it last year. You may have learned it as Hero's formula. Sometimes it's called Hero, sometimes it's called Heron. I don't really know why. But maybe they thought he was a hero. But this is Heron's formula. You need both of these right here. Does this look familiar? No?
Yeah, I've never seen this now.
Okay. You can use Heron's formula if you know 3 sides of a triangle. Yeah, and I don't know why our book does this. I mean, this big S is like area. I don't, it bothers me. So if I were you, I'd replace that with area. Okay, so what's going to happen is you're going to take 1/2 times side plus side plus side. And you're going to take that number and you're going to throw it into this formula. So you have the square root of this S times S minus A times S minus B times S minus C. Okay, so you're going to take your 3 sides and you're going to add them together, cut them in half, and then plug that number into that square root formula. So we will do an example. I will have you write down these 3 sides. 43, 89, 120. So we're going to find little s by taking 1/2 of the sum of our 3 sides. What does that end up being? 126. That's a nice number. So when we find our area, we're going to set up our area by taking this giant square root of s times s minus side times s minus side times s minus side. And if I'm being honest, don't try to find each of these differences. Plug it into your calculator exactly the way I have it written up here. Square root of 126, parentheses, 126 minus a, parentheses. Okay, just plug it in all at once so you don't have to spend time calculating those things and writing them down again. Just punch it all in like that. Okay? Dallas, you have an answer? Does anybody agree? Uh-oh. Probably missed a parentheses or something. Okay, so let's recap. We will have a quiz Friday over both the law of sines and law of cosines. Tomorrow, we will do an activity involving our Star Wars clip. If we do not have school, I will post the review on my website, and my expectation would be that you practice a few more problems before Friday. Okay? Okay.
Yeah, I was thinking,